Hi guys, and welcome to yet another Unity Devcast. Today I'm going to talk about a small utility that I did because last week we were talking with our guys in our company that we needed a runtime transform handle for our editors, basically to edit our levels and stuff like that. So I looked around for various implementations on the internet and on the asset store as well, and none of them actually quite fit. They are either very simply and don't really cover all the usage that we would need. Some of them are even wrongly developed, like they don't change basically on the, for example, on local metrics rotations and stuff like that. And others were part of huge projects that they weren't easy to decouple from the dependencies they had. So I decided to create a runtime transform handle myself, and this is a bit of an introductory video. It will be free to download. You can use it for whatever, and send me any feedback if there's something you are missing or stuff like that. So let's say there's an API to create the handle through scripts, obviously, but I'm not going into that. In this, you can basically create it by using a static method, runtime transform handle dot create, where you specify a target and a type of a handle you want. Here I created it in the editor, uh, basically creating an empty object with that component, and I assigned the target manually. I will be targeting this cube. You can target anything you want, but that's what we are going to target. So I didn't change any of these, so let's just change. I'll just start it up and see what it does. So basically, but with the default settings, it will create a position handle where you can basically position the object with using the axis and obviously using the planes as well. This is the standard behavior of almost all these type of handles in any 3D program. So let's just check these settings. The handle supports specification of axes that you want to support. So for example, in your level editor, if you just want to support the the x-axis only, and you can do that. You can even support like x and y axis, and obviously the plane that comes with them. So all these combinations are there. For example, you have a 2D level and you only want to move these on this 2D plane. Another setting is the space this handle is working in. So now if I change it, there is not much difference. But if I rotate, let's rotate this in the editor. If I rotate the cube in some way, now I'm in the local space of the cube. So this will work as the plane with which is basically rotated inside the local space of the cube. But if I still want to work in world space, I can change it to world space, and now I'm positioning the transform according to the world space, not the local space of the cube. Next setting is the snapping. Let's skip this one and just go to this these numbers. So you can use positional snapping with different snap values on different axes. So if you for example just want to snap on X, you see it's snapping on X, but all the other axes will be unaffected. Even if you use the plane, you see that only the X is snapping. You can snap to Z as well, and you can snap to a different value. So now the X will snap in 2 and the z in 2 and the x in 1. You can also change the snapping type. What snapping type does, if I change this to 1, 1, 1 and I check the values of the transform, I see that it snaps to the value relatively to the transform it started in. So if the position was not snapped to a value, the position we start in, it will not be snapped. It will just increase by the snap value. If I want to use the absolute snapping, it will snap to these values to the final result in the transformation. So now it will snap to 3, 4, and stuff like that. So it will basically, now you can see it snapped to the vault space. To this doesn't matter what was the local starting point of the transformation. It will snap on the final transformation, not just to the offset, to the delta of the transformation made by the handle. And the next setting that's here is the autoscale. What it does is basically it scales the gizmo, the handle, depending on the camera itself. So now if I move the camera, the gizmo will be scaled, so it's not too big, it's not too small, it's still the same. So if I just to check it out, if I change this to no scale and I just go into it has its own transform. It doesn't change uh, depending on where you are looking at it, but if you want to auto scale it at runtime to the distance from camera, it's an easy option. You can also change the scale factor, so now it will scale. It basically multiplies the final final scale with this factor, so it can be even larger or smaller. It depends how you want it. And then finally there is this handle camera. Let me stop it here. As you can see, it's none. This is useful for multi-camera scenarios, just to let the runtime transformer handle know which camera will be handling the hit testing and basically the interaction with the handle. But if there is none specified, and I run it, it will automatically assign the main camera. So let's check if we want a different type of transform handle. So we have these three, the basic three. There is this rotation handle. It will automatically show you the offset by which are you rotating, same as the Unity handle. And also we can work with delimitations, as I mentioned in the positional handle. Also you can be in world space or in a local space, as you want. There is only one snapping for a rotation handle, so and it's in degrees, so it will automatically snap to these depending on the axis you are rotating. Because if you wanted like a different snapping for different angles, it didn't really work out. It will basically mess up the quaternions, and the result is not what would you expect. Even though it's mathematically correct, it will be all over the place. So I decided to just use these. It's doable, but it's not something you you would really want. So now only, for example, if I go to local and I will use this, which is some kind of custom axis, it will snap to these 15 degrees. And as you can see, it modifies all three of the angles. And finally, let me just stop it and restart it. And finally, there is this scale with different different axes. You have this global axis that will scale the object by all three, and you can again use these limitations. Now, if you only have two axes, this will not work as a global, but it will scale by both of those two axes. So it will disregard the third locked axis as well. And obviously these all work as well. You can snap by different values on different on different on different axes. I had a small bug there. I just fixed it. So because I was just working on on it right before I started recording this video. It's already fixed. So uh, you can, as you can see, it snaps by 1 on X and Z, and it snaps by 2 on Y. So again, if you can change this at, as you can see already, at runtime, you just don't automatically checks in the update if it should create and delete all the axes that's not relevant for the current settings. And what you can do at the moment, if you want more than these, to have all three, you can create 3 instances of the runtime transform handle. I will add the support for it to do it from the code instead of having 3 of them. But at the moment, you simply create all 3. Now, if I run it, you can see that I have this ultimate gizmo that will work with all the transforms, and you can set all the settings specifically for that type. So for example, if I wanted the position to be world, you can see the position switched to world coordinate, but all these others are in local coordinates. So you can you can switch it independently. You can also like set the position will be only by Y, a rotation will be in X, and let's say scale will be in Z only. So you can have all these really custom transform gizmos and use them as you want. Again, it's on GitHub. You can download it. If you have any questions or any feedback, or there is some kind of bug like I just encountered, let me know. And that's all for now. Enjoy.